All right, so we are going to finish up chapter 1 looking at section 1.6. So we're still looking at functions. That's pretty much a lot of what we've done in chapter 1. But now we're going to look at how we can take two functions that we have, combine them together in some way to make a new one. And the first way that we're going to look at combining functions together to create a new function is just using addition, subtraction, multiplication, and division. Now, when you have two different functions that you combine together to create a new one, if you have like terms, then those should be combined. The big thing that we're going to focus on is when you have a function, it has a domain and it has a range. When you combine it with something else, you are possibly changing that domain and range. We need to figure out what that new domain and range is. Okay? All right, so let's look at these two functions. F of x is x squared plus, is just x squared. And g of x is the square root of x plus 1. If I wanted to create a new function by adding them together, okay, we're going to call this new function f of x plus g of x. It would be that. That's a new function, combining the two original functions that I had, specifically using the addition operation. Now I can't simplify that because there's no like terms. If, as an example of like terms, let's say I had x squared, and then let's say g of x was 3x squared. Well, if I add those together, that would simplify if these were my two functions. What would that add up to give me? Yep.
4x.
4x squared. Yep. But in this case, because this is a squaring function and this is a square rooting function, they are different functions that cannot be combined together. We could do the same thing with subtraction. So if you wanted to combine these two to create the function f of x minus g of x, you literally would just write that down. X squared minus the square root of x plus 1. Okay, here's an example doing it with division. Now, when you do division, we got to be careful about square roots in the denominator. The first step to doing it with division, if you want to know what is f of x divided by g of x, it's x squared over the square root of x plus 1. Okay, that's my new function. But we generally do not leave a square root in the bottom of a fraction. So what I've done in this step right here is I'm multiplying by something to rationalize my denominator. Okay, I'm getting rid of that square root in the bottom. And whenever you want to get rid of the square root, you multiply the top and the bottom by the square root. So in the top, that gives me x squared, square root x plus 1. And in the bottom, the square root cancels out. And I'm left with just x plus 1. Okay, so that is the simplified version of f of x divided by g of x. It's a new function created from the original ones using division. Just to talk about that square root in the bottom, let's just do one more of those. Let's say you had this. We can't leave that square root in the bottom. What would you multiply top and bottom by to fix the square root there? Yeah, multiply by square root of 2. And then can you tell me what you'd get for a final answer?
When you said root of 2.
Perfect. 3 square root 2 over 2. Yeah, I just wanted to do a quick example again with that square root to make sure people know how to fix that. Any question on fixing a square root if it ends up in the bottom? Okay. So there's more examples. I mean, I only did addition and division. You can do multiplication, you can do subtraction. Those are the four main operations that we can use to combine functions. We're going to talk about one more, and we're going to spend most of the time on that one later on. But let's do a little bit more with just these 4 basic operations. All right. When you combine 2 functions together, how do you figure out the domain of the new thing that you created? Well, I kind of think of it like a Venn diagram. Let's say that represents the domain of everything in your first function. And then let's say that represents the domain of everything in your second function. The new function is the values that belong to both of the original domains. Okay? So when you combine f of x and g of x together, the new domain, it's like the overlap. It's all the values that were in the original function, f of x, and all the values that were also in the original function, g of x. Has to be in both. Now, there's only one little trick we have to be careful of, and that's with division. When you take f of x and g of x and combine them with addition, subtraction, multiplication, no problem. You can pretty much follow the concept of that diagram. But with division, you could create a problem that only comes up with division. What do we want to make sure we never do with division? Yeah, go ahead. Yeah.
Divide by 0.
Marcel, sorry. Yeah, we don't want to divide by 0. We don't want to divide by 0. So if you combine functions together and it results with a variable in the bottom, that is something else you have to check. Make sure you never divide by 0. All right, so we're going to start with these 2 functions, f of x and g of x. F of x is the square root of x plus 3. G of x is the square root of x minus 2. Before we combine them, it's better to look at them individually and figure out the domains. Okay, what's the domain of the square root of x plus 3? Yep.
X does not equal -3.
So anything except, so could you plug in -4? No. So x also doesn't equal -4. Could you plug in -5? No. Okay, so we gotta refine the domain a little bit. Yeah.
Would x be greater than or equal to negative?
Yes. X is greater than or equal to -3. Okay. What's the domain of g of x? Square root of x minus 2. Yep.
X is greater than or equal than 2.
Right. You have to plug in a number greater than or equal to 2. Now, let's combine those 2 functions together using addition and get the domain of that. When you combine these with addition, these aren't like terms. With square roots, like terms would look like this. Square root of x plus 1, let's say plus the square root of x plus 1. You can combine those together and you could say that that's 2 square roots of x plus 1. That's fine. But we don't have that here. Okay, we have different radicands, x plus 3 and x minus 2. So they're not like terms. So all you can do is this. Square root of x plus 3 plus the square root of x minus 2. But what I want to know is the domain. Okay, so what you tell me for the domain, it's the overlap between the 2 original domains. Okay, so if you're not sure, think of it like on a number line. -3, -2, -1, 0, and 2. The first function has a domain of -3 and up. Second function is 2 and up. What would be the overlap? in the domains. Yep.
X is greater than 2. Or greater than or equal to 2.
Greater than or equal to 2, yes. Those are the numbers, everything that's 2 or higher, that are part of both of the original function's domains. If you think, well, what about 1, right? You could plug in 1 in this one. Yep, you can, but you can't plug in 1 in that one. So it has to work in both of the original functions. All right, let's try this one. F of x divided by g of x. Can somebody tell me, you don't have to give me the final answer, just give me the first step for doing f of x divided by g of x. Lens?
Would you just plug in their values into the fraction? As in like, it's like rad x plus 3 goes into the numerator and then rad x minus 2 goes into the denominator.
Yep, perfect. So that's your first step. Now we're just going to clean that up because we don't want to leave the square root in the bottom. So what are we going to multiply the top and the bottom by to fix that? Yep.
Rad x minus 2.
Yep. So we're going to multiply by the square root of x minus 2 over the square root of x minus 2. Okay, bottom part's easy. That's x minus 2. Okay, square root's gone. And then in the top, when you're multiplying together two square roots, you can multiply together what's under the roots and put it under one big root if you want. So, for example, if I had the square root of 3 times the square root of 5, that is the square root of 15. You can take the 3 and the 5 and multiply them together. Okay. I could do that here. I could make one big square root and FOIL out x plus 3 times x minus 2. So it'd be like x squared, and we'd have to do out the rest. But I'm just going to leave it as two separate radicals. But you should know that they can be combined. Okay, so there's our new function created by dividing the originals. But now, I want to know the domain. What's the domain in this one? Yeah?
X is greater than 2.
Why not greater than or equal to? Because that's the overlap between these two.
Because you on the bottom will be 0.
Right. We've created an issue in the denominator where if you use 2, you'd be dividing by 0. So that's important to take into account. So the domain in this one is the overlap of the two original ones, excluding any values that would cause you to divide by 0, which in this case is 2. Okay, so small difference between the domains, but very important difference. Okay. Any question on that one? Okay, let's try this one. So let's say we had a function, these are different now than the last problem. F of x is the absolute value of x, and g of x is x. So I've taken those two functions, and I'm going to combine them together with the division operation. And this is what I got. So I did that part. I just want to know the domain and the range. What's the domain here? Yeah?
X is greater than 0.
X is greater than 0. Could you plug in a number like -2? Yeah, you can plug in negatives. Yeah?
X does not equal 0.
Right, x is not 0. That's everything except 0. So all reals except 0. Okay, how about the range? Think about like if you plug in 5, just pick a number. If you plug in 5 for x, what would you get for y? How about, Gregory, what would you get if you plug in 5 for x? 1. How about if you plug in 6 for x? 1. Okay. So, anyone have an idea what the range is going to be? Yep, G.
All rows except 0.
What if you plug in 8 for x? What do you get?
1.
1. So what do you plug in 10 for x?
Get 1.
You still get 1. So remember, range is the answer that we're getting when we plug in a number for x. Yep.
The range is 1.
No. Yep.
So 1 or negative
1 or negative 1. No matter what you plug in for x, you're always going to get either 1 or negative 1 for y. So it's a very limited range. Okay. You can see that if you type it in on the calculator. Go to math, number, absolute value of x, and then divided by x. I probably need to set my window, which I should have done first. If you plug in a negative number, you always get negative 1 for the answer. If you plug in a positive number, you always get positive 1 for the answer. If you try to trace to 0, it's going to leave it blank. There's no answer because you can't divide by 0. If you go to the table, it'll show that a little bit clearer. If you try to plug in 0, you get an error. But any other number besides 0 is either 1 or negative 1. Any questions on that one? All right, so combining functions using addition, subtraction, multiplication, and division, it's pretty straightforward. We're going to look at another way that we can take two functions and combine them together, and this is what we're going to spend the rest of today, and that's called composition. So composition is another way to take two functions, merge them together, and get a new result. So how does composition work? Very quick summary of composition. It's when you take one function and you plug that in for the variable in another function. That's composition. Take one function and fill that in for the variable in another function. So let me show you how that works. Okay, here are your two functions that we're going to work with. G of x is the square root of x. F of x is x squared plus 3. This is the symbol you will generally see when they want you to do composition. The way you pronounce it, every time you see a left parenthesis, you say the word of. So that's g of f of x. So if I was going to do g of 2, I would take what's inside here, and I would fill it in for the variable. So that would be the square root of 2. If I was going to do g of 7, I would take what's inside here, and I would fill it in for the variable. Okay. What we're going to do now is g of f of x. So what that means is, well, let me show you. G of, now you're not putting in a number for g. You're filling in this formula. What's the formula we have for f of x? Yeah.
X squared plus 3.
X squared plus 3. So now, in function g, you are replacing that variable with this entire formula. Okay? It's not just a number you're filling in, it's a formula you're filling in. Okay, so now let's do that. Look at function g, And everywhere that you see a variable, replace it with f of x. So it's going to be the square root of x squared plus 3. That is g of f of x. And that cannot be simplified. That's as simplified as it gets. So now, the question sometimes we get is, well, what happens if you switch it around? Is g of f the same as f of g? Well, let's see. So f of, what's our formula for g of x? Yep, Lens.
Rad x.
Yep. So now, you're always taking what's here and you're filling that into the function there for the variable. Okay? So this time, they want me to take g of x, which is the square root of x, and plug that in for the variable in function f. Okay, so now go back up and look at function f. It's x squared plus 3. So everywhere you have a variable, which is what I just circled, change the variable to square root of x. So we're going to have square root of x squared plus 3. Which is going to simplify to x plus 3. So no, f of g and g of f are not the same thing. The order that you compose the two functions in makes a difference. Right. Any question on how I got g of f or f of g there? Plugging one function into another function. So we're going to do a few more of those, but we want to get into also finding the domain. It's not too tricky if you follow the rule I'm going to give you, but I do need to explain how to do it. Another notation you might see in the book, I don't use this notation as much, but if you see a function and a little circle and then another function, this means that. I always write it this way because to me that just makes more sense and I'm used to function notation. Seeing the parentheses. But just understand that this is the same as that. Okay, so how do you find the domain if you've taken two functions and composed them together? 2 steps. And I kind of think of these steps as like filters. Okay, so I start with all real numbers, and I'm going to start filtering out what I know doesn't work. So the first step is eliminate any values, bless you, that are not in the domain of the inside function. Okay, what do I mean by inside? When you compose, you have 2 functions. This is the inside, that is the outside. So the first thing I would do is look at the inside function and ask myself, are there any values I need to eliminate from that one? What kind of values would I need to eliminate? Anything that causes me to divide by 0, anything that causes me to take the square root of a negative. So that's the first step. Start with the inside function and eliminate any values that are not part of the domain of that one. Now, next, you're going to look at the final answer. This is a final answer that we got. You look at that and you say, okay, are there any values that I need to eliminate from that function? And in this case, the answer is no. There's no fraction here. There's no square root here anymore. Okay? So looking at the composed function, There are no additional values I need to eliminate. So you would know you need to eliminate something if the composed function has a square root in it. That could be something you need to look at, or it has a fraction with a variable in the bottom. All right, so now let's practice a little bit more with composition, and then we'll also practice finding domain. Range, well, range is a little bit harder, but we can use the calculator to help us get a visual when we do range. Okay, so we're gonna stick with domain for now. We'll do range in a little bit. Okay, this first one is purely a numeric problem. It's just asking you to come up with a number for the answer. F of G of 9. When you have a composition, you start on the inside and you work your way out. So the first thing I'm going to do is this. Find G of 9. What's my formula for function G in this case? Yes, Evan?
Square root of x.
Square root of x. And what number do they want me to fill in for x in function G? 9. Yep, so that's the first thing I'm going to do. Don't worry about the f on the outside, just worry about G of 9. Take the 9 and fill it into function G. So square root of 9. Okay, square root of 9 is going to give me how much? Yeah, 3. So now they're asking me to find f of 3. Okay. So take the 3 and fill that into function f. If I fill 3 in for the x in function f, what would I get for my final answer? That's 4. Yep. So that's purely just a numeric problem illustrating the idea of composition without any variables. That's the only numeric one we're going to do today. Now we're going to go back to variables. So now, instead of finding f of g of a specific number, let's find f of g of a variable. Okay, so start the same way. Function f is on the outside. Replace g of x with the formula up above, square root of x. So now we're finding f of the square root of x. Now, fill that into function f everywhere you see a variable. So can anybody tell me what f of g of x would be? Yep, Nick?
The square root of x plus 1.
The square root of x plus 1. There you go. I guess we're not doing the domain on that one. We're just composing them. Okay, let's do g of f of x. Ethan, what's f of x again?
X plus 1.
X plus 1. Okay, so we got that written down right up there. So I substituted in for the inner function. Now take that and fill it into function g. What's g of x plus 1? Yep, Jackson.
Square root of x plus 1.
Same as the one up here?
The whole.
The whole, yeah, the whole thing. So there is an important difference there. This is a horizontal shift of the square root. The top one is a vertical shift. Okay, we should kind of be able to reason that through from what we learned yesterday. Okay, any question on composing those two? All right. So let's do some domains now. Let's do g of f, and then we'll do f of g. Okay, so we've got g of, and then look up the formula for your inside function. Now, replace the variable in function g with x squared minus 1. That's the composition, the square root of x squared minus 1. Now I want the domain. 2 steps to finding the domain. What did I say to do for step 1? Yeah?
Eliminate the values that don't appear in domain of inside function.
Eliminate, say that again?
Eliminate the value, eliminate any values that do not appear in the domain of the inside function.
Yes, eliminate any values that would not work in the inside function. Okay, the inside function is x squared minus 1. Are there any values you are not allowed to raise to the second power? What do you think, Lens?
I don't think so.
No. Remember, the only thing you're looking out for is dividing by 0 and square roots. That doesn't have either of those. So eliminating any values from the inside function, there are none to eliminate. Everything works in the inside function. Now, step 2, look at the composed function. Does the composed function have something we need to be careful with? If not, then the answer is all real numbers. If it has something we need to be careful with, then we need to figure that out. So what do we think? Is there anything there we need to be careful with? Yeah, Travis?
Square root.
Right, that's square root. Okay, so there are going to be some values we need to eliminate because we never want the square root to be what kind of number? 0 is fine. Square root of 0 is 0. We just don't want the square root to be a negative. Okay, so you never want what's under the square root to come out negative. In other words, what do we want? We want it to be 0 or higher. So I always want x squared minus 1 to be 0 or higher. So that means I want x squared to be bigger than 1. I said 0 or higher. Sorry. I didn't write the or higher. 0 or higher part. So that means we want x squared to be greater than or equal to 1. What kind of numbers can you square? And they'll come out 1 or higher. Yeah.
Any number except 0.
Well, if you square 0.5, you get 0.25. So that's not 0, but if I square 0.5, I don't get a number bigger than 1. Sense?
Would it be all real integers except 0?
All real, well, you could square 1.5, and that comes out bigger than 1. But 1.5 is not an integer. That's a rational number. Yeah?
X would be greater than or equal to 1?
Okay, that's part of it. So you could pick a value greater than or equal to 1. And if you square it, it will come out greater than or equal to 1. What else? Yeah?
Less than or equal to negative 1?
Or less than or equal to negative 1. Yes. If you square, think of it on a number line. Here's 0, 1, negative 1. You can pick anything in this zone If you square it, it'll come out bigger than 1, or anything over here. You just can't pick anything between -1 and 1. If you square that, it'll come out less than 1. Okay, and that was the only restriction in this problem. The inside function was perfectly fine, so we didn't have to worry about any restrictions there, but the composed function did have a problem. Okay, so now we've taken care of that. Right, let's try f of g of x. So g of x is the square root of f, square root of x. And now fill in the square root of x into function f. So x squared minus 1. Change the x to square root of x. That's basically your template. That's the function f. Now fill in what they want. Square root of x. Okay. What do we get when we simplify that? Yeah?
X minus 1.
X minus 1. Now, if somebody just came in here right now and that's all I showed them and said what numbers you were allowed to plug in for x there, well, that's all real numbers. But the problem is that came from something that originally had an issue, and that issue canceled out. Well, the fact that that issue was there to begin with is important. So let's start with the domain of the inside function. What's the domain of g of x? Yep, Jackson.
X is greater than or equal to 0.
Right. So we're already starting with that. Forget about anything else. We're already starting with numbers that have to be greater than or equal to 0. So keep that in mind. Now, let's look at the final answer. Is there any restriction just looking at that itself? Is there any restriction on x minus 1? No. You can take any number you want and subtract 1 from it. So the only restriction on the domain in this problem came from the original inside function. And that limited us to numbers greater than or equal to 0. So the point is, even though the composed function doesn't have a restriction itself, the original function it came from did. And that's important. Yep.
Can I return them?
Yep, just sign out for me. Now, if you type that in on the calculator, and you just type in x minus 1, it's not graphing greater than or equal to 0. It graphed the whole line. That's because when you type in x minus 1, how does it know that this x came from the square root of x squared? It doesn't. Right? If you type it in this way, then the calculator will know that there was a square root there to begin with, and it's canceling out, and it will draw it properly. So you type in square root of x squared minus 1. Now, it only draws it 0 and up because it knows the original function was a square root. Any question on that? Okay, range. Well, range, we're really going to use the calculator to help us figure that out. So this part right here, the second part, that's where the calculator comes in. But you do need to figure out the domain first, because you need to set your window. If you don't know your domain, how are you going to set your window to look for the range? Okay, so you should have an idea of what your domain is first. Okay, and the next one, I'm not going to do both ways. I'm just going to pick one way, either g of f or f of g. Doesn't matter. And it takes a little bit of practice to get good with the domain and range, especially of composition functions. But if you follow the rules I gave you for the domain, and use the calculator to help you with the range, then you should be okay. Okay, so step one, first determine the domain. So for this one, let's do, let's just do the second one. Let's just do f of g of x. And let's find the domain and the range. Okay, so first step, find the composed function. Then analyze it to get the domain and the range. All right. Anyone think they can tell me final answer for f of g of x? Yeah.
Square root of x minus 3.
And can you tell me how to write that?
F of g of x equals the square root of x minus 3.
And can you be more specific about the square root part?
Oh, x minus 3 is all in the square root.
All in the square root, yes. If you composed it the other way, g of f, it would also be the square root of x minus 3, but it would just be square root x minus 3 on the outside. Okay? So that's your composed function. And now let's do the domain. Start with the inside function. That was g of x. Are there any domain restrictions on g of x? Anything, Marcel? No. Minusing 3 from a number, that's fine. So no restrictions on the inside. Let's look at the composed function. Is there any restriction on the composed function? None?
I think x is greater than or equal to 3.
Yes, there is a restriction, and you also answered it. It does have to be greater than or equal to 3. So now, when I do my calculator, I'm probably going to set my x min at 0. I'm not setting it at -10 because I don't need to look that way. All right, so let's type in on the window. Let's do the x min at 0. I think that'll be fine. Now, nothing canceled out here. Like when we had a square and a square root and they canceled out, if the calculator doesn't know about them canceling out, it's not going to draw the right picture. But nothing canceled out here. I just filled in this right there. So you can type it in exactly the way you see it in the final answer. Square root of x minus 3, hit graph. There's your square root function starting at 3. And remember, square root function is a sideways parabola. So if I keep zooming out, how high is that curve going to go?
Infinitely.
Infinitely high, yeah. So this curve is going to go up forever. How far down does it go? Yeah.
0.
It goes down to 0 and it will hit 0. So the range is 0 and up. Okay. So the range is really helpful to figure it out. If you're not sure, well, does this curve keep going higher and higher? Go to your table and just try numbers. If you plug in 500, you're at a y value of 22. 10,000, you're at 99.9. If you go to 50,000, you're at 223. So it just looks like it's going higher and higher. It's not leveling off and stopping. And square root functions never do. So now, let's try this. So I want to finish up by tying what we learned in yesterday, which was transformations, into what we just learned today, which is composition. So what I'm giving you here, and you have to think about this a little bit. I'm giving you the answer for when you compose two functions together. It's ax squared. That's the answer. That's what you had to figure out before. What I'm asking you is what would be one of the original functions to create this composition. I'm telling you one of them. F of x is x squared. I need you to tell me what g of x would have to be. Anybody think they know what g of x would have to be so that when you fill in f of x, which is x squared, you end up with ax squared? Yeah? Well, it's got to be something with a variable, or we wouldn't have a spot to fill something in. So think of A is like a constant. It's like a vertical stretch. It's multiplying by a number in front. Yeah? Ax. Yep. So now, if this was your function, and you took and you filled that in for the letter, replace that letter with what they're telling you to, you would end up with ax squared. Okay, so composing this function with this function gives you that function, which is a vertical stretch. Let's try this one. X squared plus k. Okay, that's the composition. Okay, f of x is given. That's x squared. What you have to figure out is what would go in that box, so that when I do g of x squared, I end up with x squared plus k. Yep.
X plus k.
Perfect. X plus k. Now, if you compose them, g of f of x, if you take f of x, which is x squared, and fill that in for the variable right there, you would end up with x squared plus k, which is what they wanted you to get. Okay, so it's a little hard to think about at first, but that's composing two functions together to create a vertical shift. That's what that's doing. All right. So we already talked about this yesterday. When you put a negative in to a function, like that, you get a reflection over the y-axis. Now this one you would see. I know normally with a parabola you don't see it. But because you shifted the parabola off center and then you're going to reflect it, you would notice that if you were to graph it. Okay, so what I want to finish up with is just summarizing all the transformations we learned yesterday, but in a more general way. Okay? Not specific to just quadratics or any other function. Okay? Just in a very general way. Okay. Does everybody have that? Okay. All right, so yesterday we examined all the different transformations, but just in relation to quadratics. We can generalize all the transformations I taught you to any function we're going to study all year. Okay, so I'm going to use some variables. The variables I'm about to use represent any positive real number. Okay, I'm going to wait for people to get that top part, and then I need to zoom in a little bit. Let's try this. Vertical stretching and shrinking. So this is the left side of my chart. What arithmetic is involved when we stretch or compress something? Was that an addition, subtraction, or was that a multiplication? Yep.
Multiplication.
Yes, that was multiplication, and it was in front of your function. So multiplying by a letter in front of the function is how you do a vertical stretch or compression. All right, let's look at the next transformation. Shifting up or down. What kind of arithmetic is involved if you want to shift a function up or down? Yeah.
Addition or subtraction?
Addition or subtraction. And where do you do the addition or subtraction? Inside the function or on the end of the function?
On the end.
On the end. Yep. So if you add or subtract a number on the end of your function, that will shift it up or down. Any function, okay, not just parabolas. Okay, next one. Shifting left. What kind of arithmetic would shift something left? Yep, Raj.
Addition.
Addition, inside or outside?
Inside.
Inside, perfect. If you add a number on the inside of the function, it will shift it to the left. How do you shift it to the right? Marcelo?
Subtraction.
Yep, where?
Inside.
Subtraction on the inside. Yep. Subtracting on the inside of a function will shift it right. And when we do a reflection, what causes a reflection in a function? The function has to have a what symbol in it?
Negative.
Yep, a negative symbol. And if you want to reflect over the x-axis, is the negative symbol on the inside or the outside? Think of reflecting over the x-axis as a vertical reflection. That's a vertical reflection. Does the negative go inside or outside? If you're stuck, think of where the other vertical transformations are. Are they inside or are they outside?
Would it be inside?
Inside is always the horizontal transformations. So this one would be outside. Yeah. Right? The negative is out in front. And then if you put the negative on the inside is always horizontal. That's horizontal because it's inside the parentheses. All right, so now let's take that graph and we're going to transform it, but I'm not going to give you a formula. I'm just going to give you an image, and I want you to transform the image. So there's no formula for it. Let's do make it a little quicker. Let's do that to it. I'm going to do 2 transformations to that picture. Let's start with that. What's the +1 going to do? Yeah?
It's gonna shift left 1.
It's going to shift left 1. So every point that I have on here is going to shift left 1. So that point goes there, that point goes there, that point goes there. Again, no formula. You're just shifting the image using the points. And what about the 2? What's that going to do to the picture I just drew right there? Yep.
It's gonna stretch the graph by a factor of 2.
Yep. And what part of the coordinate does that alter if you stretch it vertically by a factor of 2?
It would affect the y values.
It would affect the y values. All the y values are going to double. The x values are going to stay the same. What's the y value of this point right now?
0.
And if you double it,
0.
still stays at 0. Yep. Y value of this point is 0. If you double it, it stays 0. Y value of this point is 2. Double it, 4. There's your vertical stretch by a factor of 2. And that's it. So there's no formula, you're just taking the image and doing the transformations. And I had some more space for graphing. Okay, and those are the questions for tonight. Okay, so we'll take a look at that next time we have class. And we'll have our first test next academic week.